Hello everyone, welcome back to my channel. My name is Piyush and this is video number 18 in the series CK 2024. And in this video, we'll be looking into health props in Kubernetes, liveliness prop, readiness prop, startup props, and so on. We'll be doing some demo and we'll be looking into the concept in detail with some hands-on practice. And yes, there'll be an assignment for you, a task for you to complete by your own for the hands-on for the practice. And it'll be there in the GitHub repository as always in day 18 folder. And the comments and likes target of this video is pretty simple. It's 200 comments, 200 likes in the next 24 hours. I'm sure you would be able to do that. And without any further ado, let's start with the video. Okay, so before looking into the demo, let's quickly look at the concept of what exactly are these health props at Kubernetes. And before that, before even looking into health props, let's understand what exactly is this prop. Is this a buzzword? Is this something that you should be worried about or something to understand? Let's have a look. So props is nothing but something, some system, some process, something that is monitoring your system and taking some necessary actions to either recover the health or to grab some status or to make sure that everything is working fine. So it's robbing someone is means inspecting someone, interrogating someone, or monitoring someone, right? To take some necessary actions. Then what are health props in Kubernetes? Health props is like there are three type of props: startup props, readiness prop, liveliness props, and all of these make sure that your application is healthy. The application is self-healing, means when it is failed, it should be restarted automatically to recover from the failure, and your user should not be impacted. So that's the main purpose of these health props. So first one is, let's say, liveness prop. What liveness prop does, it actually monitors your application. Like all the props, they does nothing but do the continuous monitoring of your application after a certain period of time, let's say 10 seconds, 15 seconds. So liveness prop does the same. It monitors your application, and sometimes your application, let's say, is failed or crashed due to intermittent network error or some application error, something that could be recovered easily by just restarting the container. So it monitors that and it takes just necessary action. It restarts the application if it fails, and it keeps on restarting it. After a while, if it does not restart, it will throw the error. So you will have some time to fix the issue. Even though the restart does not fix the issue, you will have some time to investigate this and fix the issue, and you will get the alert that your liveness props are getting failed. Means something is wrong with the application, something is wrong with the health checks that these props are doing. Then we have readiness prop. Readiness prop ensures that your application is ready before it starts serving the traffic to the user. Like, let's say you have okay, let's take an example. Let's say that's your application. It's running in 3 different pods, okay, and they all are behind the load balancer. So these are 3 applications, and let me add a load balancer. Okay, let's add anything. Let's add Azure load balancer. This is just an example. Okay, so here are your users trying to access the application from load balancer, and load balancer is then redirecting the traffic between these application pods. So these applications are part of the same deployment, and your application will be served by one of these pods. But let's say there is an application that takes at least 20 seconds or 30 seconds to boot up, to be started completely, right? So till that time, your users will be getting 502 errors or 5xx error that your application is down. So to prevent that from happening, it makes sure that your application will only be added to the load balancer, or it should only be ready to accept the traffic from the user once the readiness props are passed. And it will wait for certain time. It will not prop the application unless it is fully started. So this is another important props that we will look into. And so if it's still confusing, don't worry. When we do the demo, it will be pretty clear, I'm sure. So just be with me, just follow me along, and I will make sure that by the end of this video, readiness, liveliness, these props are, it's pretty simple. So then we have startup props. Startup props are mostly used for slow or legacy container applications. So application that takes a lot of time to start up. Right. So readiness probe only, make sure that your application is ready. Only then it will serve the traffic. But then for some of the legacy or slow application, this time could be a lot of time. Right. So for that, we add an additional probe, a startup probe, and it will make sure that, let's say, your application will wait 5 minutes before it starts serving the traffic, and only then the rest of the props will be active. So first the startup prop will be active, it will make sure that it works, and only then readiness and liveliness prop will be active. So we use a combination of these props in a production environment, and mostly liveliness and readiness prop. Both of these props we use for all the applications. So that's one of the best practices. So now let's have a look at the demo. Let's have a look at the implementation of these props. Well, I forgot to mention earlier, but we have three types of health props, and each of these three health props can perform either of three types of health checks. So it could be either HTTP, it could be either TCP, or it could be simple command. So with HTTP health checks prop, what it will do, it will send an HTTP request to an endpoint after, let's say, every 10 seconds or after 15 seconds, and if it is getting the response back as success, then only the health checks are successful. In case of TCP probe, it will try to open a port on certain endpoint, and it will, based on the response, it will fail or either pass the health check. And same thing with the command, it will execute a command against the endpoint, and if the command results in a success response, then only the health checks will be successful. Okay, so let's have a look at each of these three with the help of an example. So first, we'll look into the command health checks for liveliness. So it's nothing but we have a pod. Okay, inside the pod we have a container, and it uses an image. Okay, so till here it's pretty basic, pretty simple, whatever we have done earlier. And it uses a busybox image. We have used this particular image previously as well. So it has a few binaries, few executables, and it actually runs those commands, whatever we have specified as part of command and argument, and then it gets completed. Or it's not an ongoing pod, it does not have an operating system that keeps on running it. So it's kind of an image that we use when we have to run some arbitrary commands or inline commands, and that's all about it. So as part of this, what we are doing is we are opening a shell and we are running these commands. So let's have a look what this is doing actually. So with the help of touch command, it will create an empty file with the name healthy, and that file will be there in the temp folder. So touch/temp/healthy. Okay, so file is created, and then it will sleep for 30 seconds. That means it will not do anything for the next 30 seconds. After 30 seconds, it will remove the file with the help of rm command, and after that it will wait for 600 seconds. So it will not do anything for the next 10 minutes. So how will probe works in that? First, have a look at the probe. So this is the syntax of how we use props. So we have liveness probe. So we write liveness probe, and again these props are part of containers. So it has to be a child object of the container, right? So here are our containers, and liveness probe is inside the containers, right? So make sure you do the indentation properly. So we have liveness probe. Inside that we are using exec because we are using a command. So exec and this command. This command is again an array of multiple commands, and what we are doing a cat on temp healthy. That means this liveness probe will issue this command against the endpoint, against the container, and based on the response, it will make sure that your application is healthy or unhealthy, right? And then we have these two properties. So first one is initial delay second. That means before performing the first health check, it will wait for 5 seconds, right? So because let's say some applications does not start up instantly, it has to boot the operating system, it has to run some dependencies, run some commands, and then only it will come up. So for that, we specify the initial delay seconds. Usually it's between 10 to 30 seconds in the production environment. That's what we set based on the application boot up time and so on. So we have initial delay seconds. I'm sure this will be clear now. And then we have period seconds. Period second means the interval after which this liveness probe will keep on probing the endpoint, right? So every 5 seconds, it will check if the application is returning healthy response or not. And how it is checking? It is checking by doing a cat on this file. And initial delay second, I'm sure now the difference between these two properties are clear. So it is important to understand these two. So initial delay second, I'm explaining it again. So the initial delay second will be the number of second your health checks will wait, your liveness probe will wait to perform the first health check. Right. So first health check will be performed after 5 seconds. And what is the frequency of these health check? That is defined by period seconds. Like after every 5 seconds, so it will wait for first 5 seconds. Then after every 5 seconds, it will perform the health checks. Okay. Now, what would happen in this case over here? So first, when the container starts, a file will be created instantly. Then it will wait for 30 seconds. And while it is doing that, initial delay is 5 seconds. So the probe will keep on hitting this endpoint and it will get a successful response on this endpoint because this file is present. But as soon as this 30 seconds are over, and when the file is removed with this command, this health checks will start failing because now we don't have the file anymore, and doing a cat on the file that does not exist will return a non-zero error code, right? In Unix, the error code is 0 for a successful response, and like rest of the error response like 1 to 7 or anything else is an error response. So it will return a non-zero value which will fail the health check, and that will prompt the application to be restarted. So Liveness probe will take the action and restart the application. Now let's see how it is done. So I'm inside my day 18 folder. Okay, so let's apply this file liveness1c.yaml. Okay, let's see and do a get pod. Okay, now it is container creating. Okay, it's running. Now let's do a watch on this. Let's wait for that 30 seconds to be over so that the file will be deleted and props will start failing. Okay, let's wait for. Okay, you see, it is running, but it says it restarted 2 seconds ago. So the pod was restarted because the prop started to fail. Now, if you do a describe on this, describe pod liveness exec. Okay, and you will see over here. Okay, you see, it says unhealthy. Liveness prof failed. Can't open this file because it does not exist. So it killed the container. This killing kubelet killed the container. Liveness prof failed and it will be restarted. So after that, the container was restarted and it pulled the image again and it created the container again, right? And it will keep on happening. So if you do get pods now and if you wait for a few more seconds, the application will be restarted again because the prop will be failed again for the next 10 minutes as we have specified as sleep 600 seconds. Okay? So that's what it will do. Now let's clear the screen. Okay, and let's look at the next example, which is the HTTP probe. Now, what we have seen is the command type of probe that we have used. It will execute a command against the container, and based on the response, it will create, restart the container, or send the health check status whether it is passed or failed. So the way HTTP probe works within a liveness probe is syntax is same. It just instead of exec we have HTTP get because we are issuing HTTP get request against a path. So this is the path slash health. There'll be a folder or there'll be a file slash health inside the container. And we have opened port 8080 on that. And it will have the same properties, initial delay second for 3 seconds, period seconds for 3 seconds. And if we don't get the response back from this, it will fail. Right. So we are using a different image for this particular pod and rest all are the same. So if we do cat apply -f liveness http get pod container creating. Okay, it's running now. So because we are getting response back from the health endpoint, it is showing the status as healthy and liveness prop is working fine. So if you do a describe on this, oh, not here, sorry about that. Describe pod hello. Okay, so it says successfully assigned this to the node, pulling image, successful pulled image, then kubelet created container liveness, then started container liveness, and it was unhealthy in the beginning because it took some time. The initial delay second was 3 seconds, but it took more than that. That's why initially it was failed with the error code 500, but and then it says container will be restarted, and then it started the container. So if we do a get pod, the health check is not returning the response correctly. That means there is no slash health file present in the folder. That's why it is restarting the application. You see, we already have 3 restarts happen in the past 65 seconds. So after every 3 seconds, it props and it keeps on restarting the application because there is no file. We can do that with, let's do a kubectl exec inside the folder, inside the container, and hyphen sh bash. Okay, and if we do cat slash health, there is no file present over there. Okay, no file. That is why it is not getting the response back. Let's say if we create a file, touch, the container exited because it restarted the container while we were doing it. Let's do it's again, and let's do it quickly this time. Else. Okay, so we have created the file now. Okay, it exited again because it restarted it again. If we do a get pod, hello have gone now in crash loop back because the prop failed for continuously for many times, right? That's why it is now in crash loop back off status. And if we check it now, kubectl describe pod, okay, it says it will be restarted because we are getting error code as 500, and it says the application is not healthy. Even though we created the file, but because it is trying to open an HTTP connection with that endpoint, the port might not be open. That is why it is still failing. So if we do a get pod, it will still fail and it is there in the crash loop back and our container is unhealthy, right? So that's how HTTP props work with Liveness. And then we have the last one is TCP prop. So in TCP prop, unlike HTTP or the command props, in that we actually try to open a port with the container. So over here, we are opening a TCP port 8080. And if the port is open, the application will return the healthy response. Initial delay second is 15 seconds. That means it will wait for the first 15 seconds for the first probe. And then after every 10 seconds, it will try to attempt the connection again. So let's reduce it to 5 seconds. And again, we are using a different image in this. Okay, so let's apply this YAML. Apply an F liveness hyphen TCP. Created, get pod. Okay, it is running now. And let's see. Because the port is open, right? It will not, I think it will not restart, but it hasn't done its first probe yet because the initial delay was 15 seconds. So now it should be good. Let's see if we do a describe on this. TCP pod, and it says successfully assigned this container already present and started container. No issues with that. And get pods, there are no restarts till now. So we have the port open already and it is responding back because we have already exposed this container on port 8080. This should work fine. Okay, now let's try to make the change. Let's try to port 3000 and let's apply these changes again and let's see if it makes any change. So I'm gonna apply this YAML again, TCP. Okay, it says I cannot change it or something. Okay, it says invalid. Pod updates may not change. Okay, so I have to force restart the pod. Okay, so for that, what I can do is kubectl apply hyphen force. Okay, it should delete the pod and then restart the pod forcefully. So let's do a get pod now. It is running now, but it hasn't done the prob yet. So let's do a watch on this and let's see. Actually, there was an issue with configuring the props over here. So earlier I was doing the liveness prop check on port 8080. So our application by default listen on port 8080. So that's why it was showing as success response, but now I have swapped it. So now I am exposing the application on port 8080, but I am doing the liveness prop TCP port check on port 3000. And I've created the pod again. And now you see the application is getting restarted because the props are getting failed. So if we see kubectl describe pod, okay, it says it is unhealthy, liveness prop failed, connection refused, right? And it will be restarted. So that's what we wanted to see. Also, I would like to show you a few more things. For example, if you do kget pod and the pod name was any pod, like whatever we have ran so far. So let's say liveness hyphen tcp hyphen o YAML to generate a YAML of it. What was the name of it? Oh, it was tcp pod. TCP pod. Okay. So in the liveness prop, we have specified only two properties. One is initial delay second, and another one was period seconds, right? But if we look at too many fields, so let me go to liveness prop section. Okay, over here. So you see we have initial delay seconds, we have period second, but we have a few more fields. We have failure threshold and successful threshold. So because we did not set it, it took the default values. So failure threshold is 3 and success threshold is 1 as the default value. What it means, as soon as the prop gets failed, it will not restart the container instantly. It will wait for at least 3 failed attempts, right? 3 consecutive failed attempts. So it will probe once. If it's getting failed, it will probe again. After 10 seconds, it will probe again. And as soon as it gets 3 consecutive failed attempt, only then it will be failed. And in case of a success threshold, so as soon as it is getting one successful reply, it will make the application healthy. Like it will shows the liveness prob is healthy. So these two fields also you can add along with initial delay seconds and period seconds. So these are the other properties of liveness prob. And other thing that I wanted to discuss over here is so you see, we have some toleration added to this pod, but we did not added any toleration, right? So these tolerations were automatically added by the Kubernetes. So what it did, it added node not ready and not unreachable toleration to the pod. That means if the node is not ready, so these two taints will be added to the node, and these pod will be evicted from the node. Why? Because the node is not ready or the node is not unreachable, it will be moved to another node. So that's the high availability feature of Kubernetes. It will automatically add the toleration to the pod, and it will make sure that it will only serve the healthy pods on the healthy nodes. Okay. So that was all about liveness props. Readiness props have the exact same syntax. It just instead of liveness, we write readiness, and rest of the details are same. So let's have a look at one of the examples. So let's take this HTTP prop and I will go back to the documentation. Okay, over here you can search props and it will show you as the first results. So let's see an example over here. We have this is TCP and we have liveness. Okay, we can add the TCP, doesn't matter. So okay, here is the readiness prop. Copy this and just after this, at the same level of liveness, I can add readiness. Okay, so it should be something like this. Liveness prop, and at the same level is readiness prop. Instead of, okay, I've added that in HTTP YAML, but you can replace it with that. That's not an issue. So instead of TCP socket, we can do HTTP GET and specify path and port 8080, initial delay seconds and period seconds. So this is how you can configure a readiness prop. Readiness prop, make sure the difference between both of these. Readiness prop does not restart the application on the failed attempt. As soon as the readiness prop is healthy, only then the application will be start serving the workload. Right? So you can just apply this YAML. So now I can apply this YAML, this liveness, HTTP. Okay, I have to, I guess, force it again because we are adding the additional prop. Okay, let's do a forceful apply on that. Okay, get pods. I made the changes in liveness prop. And which file did I apply? Yeah, this is good. So it should be the pod name is hello, and you see it is running even though the container is not active because the readiness prop is not active yet. We'll wait for some time. And if we do a describe on that, so you see readiness prop is getting failed with 500 error, and liveness prop was failed again. So why it is failing? Because we are doing a health check on port 8080, and that endpoint or that path is not available on the container. We saw that, and it's not open on port 8080. So that is why the container is not ready. Okay, and now it has went in crash loop back because there were already 3 restart, which is the maximum attempt that it could make before it start failing the pod. So yeah, that's all about readiness prop. And you see the syntax is almost the same in both of these. It just they work a little different from each other. Plus readiness prop does not restart the pod. It will just ensure that application is healthy, only then it will start serving traffic. Liveness prop on the other end will restart the pod on a number of failed attempts, right? All right, so that's it about this video. I'm sure readiness prop, liveness prop, these are no more troubling you, and you have a solid understanding of how to work with those. And make sure to complete the hands-on that we did in this video, as well as I have a task for you in the GitHub repository of day 18 folder. Please try to complete that. And if you face any issues, you can reach out to me on the YouTube comments over here, or you can reach out to us on the Discord community and someone will help you. But make sure you try to attempt it yourself first and then ask for assistance if you need anything. And try to complete the comments and like target of this video as well, so that I can publish the next video in the next 24 hours. And the next video will be about config maps and secrets. Ideally we should have covered it earlier, but somehow I missed it, so now I'm covering it. So in the next video I'll be covering that. So thank you so much for watching, and I hope you have a good day. Happy learning, and I will see you soon.